Hello friends, welcome back to your UPSC. So today we'll start with another topic of geomorphology, that is volcanoes. So let's get started. So, what exactly are volcanoes? Volcanoes are the fissure or vent, that is, they are the opening connected with the interior of Earth, out of which flows out hot molten lava along with the ashes and gases, etc. See, either this or this. Okay, it is a crack or opening. Okay, from where interior of Earth is connected. Okay, so this is connected with interior of Earth, and from this pipe. Okay, this pipe, hot lava, molten lava, gases, ashes, water vapors, pyroclastic material, etc. They come out. Okay, so this is what exactly volcano is. And now we will see what volcanicity is. Volcanicity is, it is actually the study which includes all the processes and mechanism related to volcanicity includes all the process and mechanisms related to origin of magma, gases and water vapors. So how the volcano is formed and how it erupts, all this thing is seen in volcanicity. Okay, next is components of volcano. So in components of volcano we can see, here is our diagram. Now this is our opening of volcano. Okay, so this is where, from where the thing from interior of Earth, it comes out. Okay, so when it is a smaller in size, okay, its initial opening is known as volcanic vent. Okay, now when this volcanic vent enlarges, so why it enlarges? See, what happens is, this is volcano, this is its vent. So first volcano erupted, then the lava cooled down. Okay, some part of the lava stayed on the opening and it also cooled down. So when the second time the volcano will erupt, this plug will be removed, and because this plug will be removed, the opening would be enlarged. So with this enlarged opening is also known as crater, and much more enlarged opening is known as caldera. Okay, then we have volcanic pipe. This is our volcanic pipe. Okay, this pipe is the only source from where the molten magma comes from the interior of Earth. Okay, so it is a narrow pipe joining the interior of Earth with the volcanic vent. Next is volcanic cone. Volcanic cone is this thing. Now, when the volcano occurs, the material are accumulated. Okay, so see, first volcano occur, the lava is accumulated here. Then the second time the volcano will occur, the lava is accumulated here. Then for third time. So this accumulation of lava forms a mountain-like structure known as volcanic cone. Next we have parasitic cone. Now see, what happens is, when here the some debris or some volcanic bomb, it get locked here in the volcanic pipe during the eruption. So then what will happen? This area will be blocked, this pipe will be blocked. Okay, so the magma will put pressure on this pipe. So wherever there is a loose area, from there a pipe will be formed, a new pipe will be formed, and this pipe will form a new on this mother volcanic mountain. There will be a small cone will be formed, and this cone will be known as parasitic cone. Okay, this is a secondary cone. Next is magma chamber. This is our magma chamber, and this is connected with asthenosphere where molten material is present. Okay, so this is our magma chamber, and here only when the magma get collected it outbursts. Okay, next is composite cone. Composite cone, I have told you that when layer by layer, one after the other, when the lava get accumulated and forms a cone, this type of cone is known as composite cone. Next is acidic lava and basic lava. So basic lava is the one where the lava is consist of less silica. Just a second. So in the basic lava consists of less silica, because of which it is less viscous and it flows easily. So the cone formed will be having gentle slope. Okay, very gentle slope. So this is known as basic cone and basic lava cone. And in acidic one, what happens is the silica content is more, because of which the viscosity is very high, and due to this there is accumulation of lava when it cools down, and the slope is steep. Okay, now we will look into the classification of volcanoes. So volcanoes can basically be classified into two types. First on the mode of in two modes. First on the mode of eruption, and second on the periodicity of eruption. Okay, so on the mode of eruption they are of two type: central eruption type, that is explosive eruption type, or fissure type. Okay, so in central eruption type we have Hawaiian type, which is the least violent among these. Okay, so it is quiet and less viscous lava. So less viscous lava means it is having basic lava. So this is the structure. See, the slopes are gentle, and the lava, when it comes out, first time when it come out it is like this, then second time when it comes out, here it will be, then third time. Okay, so this is how Hawaiian type of volcanoes are volcanoes look like. So the basic example is Calvia volcano, which is in South Hawaiian Island. Okay, next is Strombolian type. It has medium intensity, and besides lava there is bomb, scoria, etc., which are ejected. So la- some pyroclastic materials like scoria, bombs, etc., are ejected out uh, in Strombolian islands type, Strombolian type of volcanoes. Okay, so Lipari Islands in Mediterranean Sea are the basic example of these. So you can see this is the volcanic pipe. The gases are ejected out along with the lava, and bombs are also ejected out. This is having much steeper, but not very steep, but much steeper slope. Okay, next is Vulcanian type. It is having great intensity because of high viscosity lava. So here the viscosity of lava is high, because of which there is steep slope. Okay, then the same, they are also found in Lipari Islands in Mediterranean Sea. Next is Pelian type. Pelian type of volcanoes, they are most violent and explosive and eject most pasty lava. Okay, so most viscous lava is ejected, because of which it becomes violent and explosive. Now, its example are Pelion volcano in Caribbean Sea. Pelee volcano in Caribbean Sea. Next is viscous type. Now, sorry, Vesuvius type. Vesuvius type of volcanoes are extremely violent and explosive because of because along with the huge amount of thick magma, explosive gases, explosive gases like sorry, just a second, hydrogen sulfate, HCl, etc. They comes out. Okay, they are ejected out, and they are ejected out in the form of cauliflower shape. When they are ejected out, they form cauliflower shape. Okay, so Pelion type of volcano is the most destructive one in Vesuvius type. Okay, so these are most destructive volcanoes. Next is fissure type of volcano. So fissure type of volcanoes are basically found in divergent plate boundaries. So here what happens, fracture or faults are formed. So along these long fracture and faults, there is slow upwelling of lava, sorry, magma, and this magma get accumulated, this lava get accumulated, and it cools down. Okay. Next is according classification of volcano on the basis of periodicity of eruption. So on the basis of periodicity of eruption, we have three types of volcanoes. First is active volcano, which constantly ejects lava, gases, etc. So basic example are Stromboli volcanoes or mid-oceanic ridge. So in along mid-oceanic ridge, we have many volcanoes which are active. Next is dormant volcano. Dormant volcano are quiet. See, first they erupt and they are quiet for some time. Okay. Now, Vesuvius volcano are the example of dormant volcanoes. Next is extinct volcano. So, extinct volcano is one in which the magma chamber it dries out. Okay. So, when the magma chamber dries out, there is no like there is no eruption of lava, and these are considered dead as there is no sign of explosion, and the craters are filled with water and lakes are formed. Okay, so basically we don't have any example of this extinct volcano, because the dormant volcanoes, when they erupt after 500 or 1000 years, when firstly they are considered extinct, but as soon as we don't know, whenever this magma chamber get filled, it may erupt again. Okay, so these are extinct type of volcanoes, so we don't have any example of extinct type of volcanoes. Now after the eruption classification of volcanoes, we will see into the distribution, look into the distribution of volcanoes. So we know this is our here this is our circum-Pacific belt. So this is basically the area where most volcanoes occur. Next is mid-continental belt. So here also huge amount of volcanoes are found. Next is basaltic plateaus. So basalt is formed when the lava it cools down. Okay. So basaltic plateaus, we have some part in Brazil, in Africa, then in India. So these are basaltic plateaus. Now we will see into volcanic materials that comes out of volcano. So the first volcanic material that comes out of the volcano is vapor and gases. So steam and vapor, they constitute about 60 to 90% of total gas discharge. So among the gas discharged, 60 to 90% are steam and water vapors. Okay, so steam and water vapor includes phreatic vapors or magmatic vapors. Okay, and other gases that are ejected are HCl, H2S, chlorides of iron, potassium, etc. Okay, next is magma and lava. So magma is one when the material, this molten material, is inside the earth or below the earth, it is known as magma, and when it comes on the surface of earth, it is known as lava. Okay, so basically there are two types of magma or lava on the basis of silica percentage of silica in it. We have read this, that is acidic lava which is having high percentage of silica, and second is basic lava which is having low percentage of silica. So on the basis of color of mineral, we have felsic lava and mafic lava. Lastly, in volcanic material, we have fragmental or pyroclastic material. So these are all the debris and mud or stones or ashes, etc. Apart, besides vapor, gases, magma, and lava, whatever thing that is ejected out comes under this one. So the material thrown out of volcano, along with lava and gases like dust, ashes, lapis, bombs, etc., they comes in pyroclastic material or fragmental material. Now we will look into what are the hazards that are caused by volcanoes. So first is the whole physical and cultural landscape is buried under the lava, because the lava that is ejected out is in high volume and it is hot. So the whole cultural and physical landscape. So physical landscape is natural landscape, and cultural landscape is man-made landscape like fields, houses, etc. So along with animals, human life, everything is buried under this hot molten lava. Next is poisonous gases. So we see the gases like H2S, HCl, FeCl, KCl, they are ejected out, which are very poisonous for human life and for every living organism. Okay, so these poisonous gases causes respiratory problems, so, and these can also lead to death. And when these poisonous gases they rises up, they form cloud, and these clouds lead to acid rain, which is again very harmful. Next is, due to volcanic eruption there is tremor, and this tremor causes landslide, mud flow. So because of landslide, huge the the huge amount of land is shifted, and because of the shifting, the natural vegetation or anything here will be buried under the land. Okay, next is tsunami. So most violent type of tsunami is formed when volcanic eruption occurs. So when this central type of volcano they occur, violent when violent central type of volcano they occur in the oceanic floor, what happens is waves are generated and they cause tsunami. So tsunami is generated by volcanic eruption. Next is radiation balance of earth is changed. See, when the volcano occurs, there is a coat, gaseous coat or ash, dark coating on the atmosphere. Okay, so the radiation of sun can't reach earth, because of which there is atmospheric change in the area. Okay, in the whole area. And because of this atmospheric change, sometimes climatic changes also occur. Now we have completed the volcanoes. There are some more interesting features like volcanoes, like geysers and fumaroles. So geysers are special type of hot springs. okay, which spouts out hot water along with vapors from time to time. Okay, so in geysers, what happens? Like in volcanoes, there was eruption, there was ejection of lava along with water vapors, gases, and pyroclastic material. So here, what happens is, just a second, I'm out of focus. So here, what happens is, hot water along with vapor is ejected out, and in fumaroles, what happens is gases and water vapors. So here liquid is also ejecting out, but here only gases, that is gases along with water vapors are emitted out. So now we will look into some of the examples of geyser. So the best example of geyser can be given as there are grand geysers in Iceland. Okay, so geysers, we have grand geysers in Iceland and fumaroles. So fumaroles basically they occur near volcanoes, volcanic cones. So here also there is Katami volcano in Alaska, USA. So near these volcanoes we have fumaroles. Okay. So near these volcanoes we have fumaroles. This is our Katami volcano and here we have fumaroles. Okay. So that was all for today, guys. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.